Okay, we've introduced three elements of classes: attributes, methods, representation, and variance. In other words, data's operations and properties. Now that we understand the basics of a class, we should think about how they're designed. There are so many questions that go into this topic, and to help you out, we have a class design recipe, which is kind of like the function design recipe that you've already seen, but specifically for classes. So highly recommend you check it out. It's sort of the same kind of structure. It gives you step by step what you should do. You know, the name, description, some examples, methods, so on and so forth. Take a look. You really need to if you want to understand what's happening. You don't have to follow it explicitly, but it does help you if you're getting started writing classes for the first time. Now, the themes of the recipe here are basically two parts: design before coding and information hiding. Just as a lot of thought goes into specifying the purpose and behavior of a function, you need to think about the purpose and behavior of a class. Same idea, before you get started actually writing your code. Now, the difference between the person who is writing the class and the person who is using the class is a big deal. When we are making our classes, you should be thinking, how should another person use this code that I am writing? In other words, when you design a class, whether it's for other people to use, or colleagues, or clients, or whatever, or even for yourself in the future, you want to give that person the best resources available to properly use what you've written. And one of the biggest desires that other people are going to have is how to use your class without having to know how the whole thing works. Designing classes by separating the public parts of the class from the private implementation details is something called information hiding, and this is a really big deal for object-oriented programming. One of the biggest advantages of how we design programs in this way is that once we've implemented things, we can modify it without disturbing the things that other people are using, and be sure that the code that we've altered doesn't affect other code that might be involved in using the class. This course is not going to go into all those details. You will probably have to wait till either 207 or is it 301, I think, the software engineering, if you get into that, to give you the opportunity to write lots of code that other people might be using. But do bear in mind that even in this course, you are writing code for one other person, which is usually your future self. We recommend you follow the class design recipe and think about separating between what you need to implement a class and what does someone need to use the class. Now, as we've mentioned, this class design recipe has a lot of emphasis on the difference between public interface, private implementation. So far, we've been using a lot of documentation to define interface. So if someone wants to use a class and you've done a good job, they very often can just rely on your documentation to use things. But in this section, we'll talk about another way that we can document attributes and methods that we want to keep private, and go over pitfalls about privateness, specifically in Python, which, spoiler alert, Python's really terrible for it, actually. A common Python naming convention is to name anything that's supposed to be private and basically not used by anybody who is trying to make use of your class, is to put a leading underscore in front of it. So instead of likes, if we wanted to make that a private thing, we would do underscore likes. The underscore indicates to programmers, people writing code that uses your code, that they should not try to access this variable. It's something that's supposed to be private. They shouldn't use it. They shouldn't change it. We can do the same thing with methods as well. What's the point of a method that other people can't call? Well, it could be a method that one of your other methods calls, in which case you want it to be able to do that. And that other method might be one that is actually part of your interface, something that people are supposed to be using. Now, Python is a little naughty in a sense, in that in other languages, when we put a restriction on when you can access an attribute or a method, they are enforced as part of the language. So for instance, in Java, if you try to access or modify an attribute that's private, you will straight up get an error. Java will refuse to let you do it, and the program will not run at all. In Python, the response is instead, we're all adults here. I'm sure you'll be mature and responsible about accessing data that maybe you're not supposed to. So the idea is that the language itself gives your programmers as much freedom really as they need to, which includes allowing you to access private attributes and methods. There are some Python ways to try to restrict this, but they're out of this course. We're not going to see that. And there are also ways you can get around those, which defeats the whole purpose. So from the Python philosophy, if someone wants to use your class, it's their responsibility to do so properly. And if they don't, well, that's on them. They decided to do that. If they access private attributes and methods that you thought that they're not supposed to, they need to be aware that this might lead to unexpected results. This doesn't mean that we should just give up on private methods or private attributes. The whole point of why it's important to be public versus private is still relevant, and most Python programmers will respect this. It also means it's really critical that you write good Python documentation and code conventions so people can see what is supposed to be private. It's not enough to just implement methods that enforce your invariance. A programmer might decide, oh, I want to actually change some of these directly for some reason, which means that you need to document the invariance that other people should be aware of if they are going to be making these changes and maintaining invariance. This way, you give the users enough information to use your code the way you've intended it to and alert them to what they should not be doing. And if they ignore it, that's on them. Now, a class is almost never used by itself. Generally, it's going to belong to a collection of classes, most of which are related to each other in one way or another. One type of relationship between these occurs when the instances of one class have an attribute, which is another class. So you might have a user object that has a list of tweets. Colloquially, you can say a user has some tweets, or a user object, so this is a little more specific, has a list of tweets that is an attribute. And we'll say these mean the same thing. So here we have our user ID, which is a string. The biography of this Twitter user is also a string, and a list of tweets, which is a list of tweets. This type of a relationship is called composition, where you have one class that relies basically on another class. And it appears all the time in object-oriented programming because it's kind of natural, right? You have two classes, one refers to another, composition. It's also the case that they might be related by composition in another way. For instance, you could change tweet so that it has an instance attribute user, which is a user type. So you have users who have tweets, and tweets reference a user. So now you have a two-way connection between these things. And this means also you might have a distinction between the person who originally wrote a tweet and someone else who is retweeting it. Up to you how you design things. Now, a common programming task is to take an English description of a problem and design classes that model the problem. The main idea is that your class should correspond to what are the most important nouns in the problem. The attributes should be whatever information is needed. This could be adjectives, it could be other nouns that are associated. And methods generally should be the verbs. So here are some examples that you should try out. People is the most, I think, intuitive example of a class. You make a model of a person. A person can be identified by their name, but you might also have their age. You might have a second name. You might want to keep track of what their mood is, which could be a list of limited things it might be. Every person might have a favorite food, and then any time that they eat their favorite food, their mood becomes ecstatic. And although people are capable of anything, you can model just a few other potential options, such as what if you change your name, which you can do. If you want to greet another person, it can always have the same general structure of, hi, blank, it's nice to meet you, I'm other blank. Something that you can try implementing if you want some practice with classes. Rational numbers. Math people, I'm not really a math person, it's okay. Sometimes get annoyed at using Python because fractions are converted to decimals and then rounded, so they're not exact. You can fix that. Make a class for rational numbers. It has a numerator and a denominator. The denominator can never be 0. Rational numbers are written like this. So you can use our underscore underscore str underscore underscore to represent what a rational number should be written like. Typical operations include, is it positive? How do you add two together? How do you multiply them? How do you compare if they're equal or not? Can you convert them to string like I just mentioned? Last example. Restaurant recommendations. If you want to build an app that recommends restaurants for a group of friends, you have each person with their name, location, dietary restrictions, ratings or comments for existing restaurants. You can also have a class for the restaurants, each of which has a name, a menu from what you can determine Dishes have specific restrictions on them, locations, and then you can have code that's a recommendation system, which in addition to recommending, can report statistics like how many times has a person used the system, how many times has it recommended the restaurant, what is the last recommendation made for a certain group of people. These are all really good examples that you should try to implement if you want some more practice with coding objects in this course. Highly recommend you give it a shot. Take some time yourself to write the code. Watching my videos is all cool and all, and respect for getting to this point in them, but there is no substitute for you actually sitting down at the keyboard and getting stuff done. So give it a try.